have a weather update from Alex Boothe with the National Weather Service. He's a meteorologist from Jacksonville.
All right. So my name's Alex Boothe. You may have seen me last year. I was also at the symposium that was down in Alachua County, also Cary Forest. I'm a senior meteorologist with the National Weather Service. I'm out of the Jacksonville office. I also manage our fire weather program, among other things. But today I'm going to talk to you a little bit about the resources that you have available to you for that weather insight, those weather forecasts that you need to make good burning decisions, as well as talk about a couple other little things that we focus on in Florida, like dispersion. And then I'll talk to you about the much anticipated outlook for the fall, and then even the spring. Again, it's an outlook, so we're kind of not exactly what forecast, but just what we anticipate given some of the conditions that we see out there now. So that's what we'll be talking about today. But first, for Florida, I'm just out of Jacksonville. I'm one of 7 offices in the state that operate for the National Weather Service. We have Mobile, Tallahassee, Jacksonville, which takes Columbia County, Tampa, Melbourne, Miami, and Key West has its own office for the Keys. And then, because Pine Key does do some burning down there. Yeah. Oh, can you not? Okay. Let me go ahead and grab this. Sorry, I don't project as much as I should. So, can everybody hear me? Good? Okay. All right. So there's 7 offices in the area or in Florida, and we all provide the same information and forecasts for everyone. And some of those forecasts are the planning forecast, which I'm sure has everyone used the planning forecast? Yeah? Show of hands? Okay. Okay. Almost every single person in this room. Okay. Good. What about the point forecast matrix for the raws? That's a lot less. I figured it was going to be less hands. Still very valuable. What about the fire weather dashboard? Nice. Okay. Good. That's less hands than I expected, but the fire weather dashboard is my personal favorite. All right, so I'm just going to talk about what each product is, what it is, how it can be utilized, and how it should be utilized. So our main staple, by the show of hands, it's the one that gets the most advertisement, the one that's utilized the most among the fire weather community, is the planning forecast. And so this is issued twice a day by our office. It is quality controlled. It's provided, we provide synopsis in there about what the weather conditions are, where there's any critical weather expected. We do headline these products with red flags, fire weather watches, which lead into red flags, or can lead into red flags, and dispersion. Whether or not we're going to see lower dispersions that day, higher dispersions, things of that nature. So the one thing about this product is that we have zones in our area. So it's a large spatial point, right? So it's an average over a big area. So you go out there and you start taking measurements or saying, oh, this is a little different than the forecast. So if you're looking at a zone forecast, it's averaged over potentially a pretty large area. So you got to take it somewhat with a grain of salt and give it a little bit of grace on that forecast. But some of the variables that include, and again, it's for 12-hour periods, are your temperatures, your max and mins, your humidities, your afternoon minimums, your overnight recoveries, your wind speed directions, your peaks, and your rain chances. And also for storms and fogs, you'll see that in the weather in there as well. And dispersion index, so what the peak dispersion is expected to be at that point in the day, or at some point in that 12-hour period, and then the low end. And then also lightning activity level, which somewhat comes out of our weather and our chances for storms. And there's a few other on there as well. So this is what the product looks like. It's a little, in my opinion, I'm a millennial, so it's a little dated for my taste, but hey, it gets the job done. It's black and white text. The anatomy of it kind of follows like this. So you got the headline up there. This is where we start to talk about if there's any conditions that are, if you see this up there, that means pay attention to what's in the discussion, because we're probably going to talk about it more. And focus in on that. And so this is the area where we start talking about it as meteorologists, what you need to look for, what you need to look at, and what are the, potential cautionary things you need to, weather-wise, before a fire goes on the ground that you may want to keep in the back of your mind. You know, one thing in that narrative that we also focus on is that fog potential. You may not be able to see it because it's kind of so small, but right at the bottom of the narrative, it says fog potential. So a big thing we deal with down here, especially in the winter and in the spring, is super fog events. And so that will kind of indicate that if we do think there's potential. So we've got our zone location. It's where you're looking at, what part of the county, what part of the zone. Some of our counties are an entire zone themselves. Some of them, like Columbia County, are broken into two, a north and south. And here's our forecast. So you can see it's broken down into 4 columns. That's what we do. We basically do 48 hours, broken 12-hour sections. Just cutting in and out, I think maybe. So we got 4 columns in there, and then that's followed by the day 3 through 7, which is the extended forecast down at the bottom, which doesn't give as much detail. But it does provide you a little bit of insight into kind of the general weather conditions that are expected. Like I said, most of you guys have used this, so you probably already know that like the back of your hand. The one that doesn't look like it's used a lot is the point forecast matrix, and this is a weather forecast, but it's particularly for a point, and that point is co-located with the raws. And why is that beneficial? Well, you can look at a forecast and you can pull up raws on your phone and look at that observation. And you can do quality control yourself looking at, okay, is there deviations from the forecast? You know, you kind of do that mental math. I'll tell you what, we do have a lot of stuff going on in our office. We're not always able to do these QCing and flagging of like when we're starting to get departures in our forecast. So this is, to me, is a really beneficial product for you to use if it's available for a raws nearby. And that's one of the cons. So there is a higher temporal resolution that you would get with this product versus the planning forecast. So it comes in 3 and 6 hour periods. Very useful if you can burn near a raws. I'll switch to this one. All right. All right. Thank you. All right. Perfect. Good. All right. So, like I said, some of the cons. It's only available, so we have a lot of raws in our area because we have the Okie, we have the Osceola, and we have the Ocala. So we have a lot of raws in our county warning area for Jacksonville. There's not as many raws in other areas of Florida, but even all of our raws don't come with this forecast. So just because there's a raws there doesn't mean it's always going to include one of these point forecast matrix. They do not include dispersion forecasts. One reason is because dispersion is very hard to observe and get an actual reading on it because it's taken into account a couple of different things, which I'll talk about. And raws don't put out dispersion forecasts or observations. So it's kind of, you're not really can't really QC against anything. Another con, unlike the planning forecast, this is not quality controlled by me or another meteorologist, a fire meteorologist in our office. So it is automated. Now the forecast that's put together is not, but for that point, it is pulled out. So it's a little bit more automated versus like a spot forecast, for example. This is what this one looks like. Again, the classic black text, white background. Print it out, put it in your pocket. But so it comes with these, the header here is going to give you that raws information. This is for Okie East. And then our 3 hourly broken forecast out. So it goes out 48 hours, and then we do a 6 hour extended forecast for that same point. If you're in the vicinity of that raws, it'll give you some beneficial information. You can also, if you're really detailed and want to get into the nitty-gritty of the forecast, start comparing it with the planning forecast, if that zone and that raws is in that same area. Okay, this is a little bit more advanced. This is getting beyond the black and white text. A little bit more user-friendly. Fairly new, it's been around for a few years now. Big thing is we all have little computers in our pockets. It's mobile friendly. You can pull it up on your phone as long as you have the link, which I have on here as well. So it looks kind of like this. There's a lot to it. But if you look at it and take time to kind of peruse it a little bit, you start to really gather, how to leverage this information because it's essentially a planning forecast and a spot forecast in one. It's color-coded too, kind of helps bring the attention to some of the variables that may be more critical to your eyes quicker, as well as looking at some of those trends in the time series, and you can kind of see, what time are we going to bottom out for our low RH of the day, things of that nature. We typically have that already noted in the back of our head, but also there's some little flags down there below on those graphs. There's like little lines denoting winds. And you can see almost time of day for wind shifts, maybe sea breeze passages, things of that nature, frontal passages. It may not be perfect because it's, weathered. We try to get it as perfect as we think as it comes through, but it can show you and give you that window of time by just looking at that little chart down there. Is there a mouse? Can I use this mouse on here? So what I'm talking about right here is this right here. Oh, is this on this one? Okay. All right. So this is the one I'm talking about. Yep. So it's pretty crucial, especially if you're just trying to pinpoint the timing. And if you're on the actual website, it'll hover over and give you the readout for time and like when these switches are going to occur, or at least give you that window. So very useful. You can put it in your pocket, and that QR code is, if you scan that, it'll take you right to that page. Now, one thing I will say is this is not an operationally supported page, meaning that some meteorologist whipped it up and put it out there for everybody, and there's no back-end support for it. So if it doesn't work, it's kind of, we have to wait till it gets fixed by someone who is a meteorologist and not a computer scientist, unfortunately. But hopefully that'll change. Hopefully we've got a lot of partner support for it, which always helps us in the Weather Service. The more you and the community and the public want this, kind of forces it to actually become an operationally used web page that people depend on. So it's my favorite. One of the variables that you'll find on that page is smoke dispersion. All right, we all probably know why smoke dispersion, especially in Florida, is important. I can tell you one thing, working out west, it's not utilized everywhere. They use a variation of this, like ventilation and things like that, but essentially it describes the same phenomena for a fire. How well is it going to be able to breathe? And therefore, how well is it going to, carry fire? Is it going to intensify? Well, time for math and more charts, because I'm a scientist, and I know some of you guys are too, so everyone loves charts. This is the dispersion index calculation, because I know that's what you came here today to learn, right? Okay, well, we're going to learn it. So on this chart here, we have a bunch of lines. That's all I know. It's just a bunch of lines. Okay, so honestly, so we have mixing height, which is another forecast variable that comes, let me go on here. Mixing height, which is another forecast variable that we output in our planning forecasts, and you can find on the fire weather dashboard here on the bottom on the x-axis here. And then here's our dispersion index. Well, that's weird. Isn't that what we calculate? Why are we using that to calculate itself? I don't know. But I'll get to it here. So what we do is first we use this chart, which has a bunch of lines on it, and these lines here denote how stable the environment is. So, an unstable day is going to be like a 1. Things are going to want to rise. Thunderstorms are going to want to happen, usually if there's moisture. And then you can see where it says night. We know that we tend to be more stable. So it kind of levels off. So say, for example, let's just go through here. We had, mixing height at about 1,500 meters, so it's about 5,000 feet-ish. We go to a normal stability type day. It's just kind of ho-hum to 3. And then we draw from that arrow, that bottom arrow pointing up, to the arrow that points to the left. And then we use that value, which is about a 9, and we multiply it by our transport winds. So that's how we get that fun little dispersion index number that we all know and love. And so if we have a dispersion or a transport wind, say, of 3, our dispersion is going to be, let's do math. There it is, 27. Okay, perfect. So 27 is our dispersion. Now what if it's 10? Right. So it's a pretty big difference in dispersion for a little bit of difference in wind, right? Doesn't sound like that. I mean, 7 miles an hour is kind of a lot, but now it's an average in what we call the mixed layer, that mixing height layer. It's an average of the wind speed through that layer, which is generally from the surface to the base of those puffy cumulus clouds that you see. So what I was trying to point out there was how sensitive dispersion is to transport winds. So without transport, if you got great mixing, yeah, you'll probably get stuff lofted, but it's probably not going to disperse as much. It'll take a little bit more time. It's not going to allow the fire to breathe as efficiently as it would like. So that's just kind of one of these factors that I would like to point out about how sensitive that element is. Because I get a lot of feedback that says, why is dispersion changing so much, 48 hours out to 12 hours out? And I said, well, that transport wind increased 5 knots. That's why we went from 30 dispersion to now we're looking at 70, you know? So it's so critical to those winds. You have a question? This is in meters per second. So transport winds, you're absolutely right. So for this is meters per second, so it's about double of what miles per hour are. So if you've got 10 meters per second, it's about 20 miles an hour. So when I said that, I meant 15 miles an hour faster. So it does make a difference for this chart. We just convert all these units to fit with American units. And so we use feet, and then we also use miles per hour. So our transport winds are in miles per hour. Exactly what you see as far as the output for the planning forecast is what we use to calculate dispersion. So, and we had a hiccup in the code that ran for about 3 years. Because we look at stability, right? Stability depends upon the time of year, the amount of sunshine we're getting. There's a little bit of a hiccup that it was always thinking that it was the middle of February. So our dispersions were always a little bit more stable in the atmosphere. So we tended to get lower dispersion than we thought. So I'm sure many of you know this as well. These are the dispersion ratings that we use, and kind of just to show whether it's poor, getting fair, good conditions, strong, or excellent dispersion. And same thing goes for the nighttime periods as well. We typically see poor dispersion at night unless we get like a frontal passage with wind, things of that nature, which will keep it more elevated. So why is it poor, excellent? What makes the difference? Well, talking about just low smoke dispersions and why that's important. You see this 1994 Ford Explorer in there coming out of some pretty dense fog. Well, super fog is the reason why. Low smoke dispersion generally means that we have little wind. We cannot have much wind if we're going to have fog development. So during the cool season, if we do have smoke nearby and we have fog potential, it allows that fog the opportunity to become quite dense. Has anybody been into super fog? Show of hands. Could you see your hand? If you raised your hand in front of you, no, you can't. It is so dense. You cannot see a stoplight in front of you when you're sitting at the line to drive your car. I mean, it is very, very dense. So that near zero visibility is it's a problem because we're humans and we have to drive and get to places. And it can affect the public. So in Florida, we've had it a number of times. The deadliest weather-related incidents that we've ever experienced in our office, it's not tornadoes, it's not hurricanes, it's not rip currents, and over one period of time. It was a super fog event. The Paynes Prairie incident. So it is crucial that we are paying attention to the fog, especially if we can help it. Wildfire, it makes a lot of sense, right? I mean, it's something we can't control sometimes, but the smoke output, the forecast is very important, especially in the cool season, because that's when we get our fog. We tend to move out of that fog season late in the spring and then through most of the summer. But this is the period of time where we start to see that fog really build up and the potential for super fog, which will go through pretty much the entire spring. Now on the other side of dispersion, high smoke dispersion. Yeah, we could get some. Those fuels have to be pretty crispy to be burning like that. But in a high dispersion day, you're talking over 75. You've got deep lift mixing over a fire. You've got the smoke transport pushing over, basically pulling in fresh oxygen, transporting that smoke away. You're going to get significant fire behavior. So with prescribed fire, if there is a high dispersion day, you may see a more erratic fire behavior depending on obviously the fuel conditions and things like that you're burning in. But that can be the case, which, I'm not a fire behavior analyst, but the potential for spotting and all that stuff becomes more, problematic. It could lead to containment breaks or, more active fire or further spotting than anticipated. So that's kind of it. Is it okay if I pause and does anybody have any questions for me at all? I got one good one because that was important about the potential difference in units there. Anything else so far? Go ahead. Yes. So that's kind of what I was alluding to out west. So they use ventilation out there. It's essentially the same thing. It looks at the mixing depth and the transport winds as well. The calculation is different. I think it's like some multiplier because it's in the thousands. And they kind of multiply, I think, all three together to get a ventilation rate. As far as out here, it's very analogous. It's just what we've conformed to out here has been dispersion. As far as you start to move further and further west, it kind of goes from the dispersion, which is a lot of determines in the southeast of how that lift is going to be over that fire, and then it kind of moves into the ventilation the further you get into the complex terrain. But they're analogous, that the output as far as the number is going to be different. So there's not like a one-to-one for it, but it's essentially determining the same thing, which is the lift, the instability in the environment over the fire. You're welcome. Yep. Yeah. Yes. Sure. So, yeah. So the question is about ERCs. So that's the energy release component, and we sometimes bring that up in our narratives, in our discussions, because we are not in the ERC business as far as determining ERCs, but we know that the fire triangle exists with weather, fuels, and topography. That fuels portion is that ERC, which we have, in the last decade, we've made an effort to provide better, headlines for red flags, fire weather watches, and we used to just use straight weather, low RH, windy conditions. That's it. Well, you use that with fuels that are moist and green. Now, I guess you could have some live burning fuels, but those ERCs tell us when the fuels are at a critical level where they're dry enough to be consumed. So we use ERCs around 26, but that changes throughout the state, and then it does change regionally too. So fuels for us is the big change, and we may see changes to how we interpret our ERCs and utilize and leverage some of the fuel information to make our decisions in the future. But right now, it's just kind of that fuel component that we use to make decisions on whether or not we need to issue headlines for red flag. And fun fact, I'll take a little pause here. I know there's another question, but does anybody know why red flag is a red flag? If you do, I will give you all the money in my pocket. No? All right, do you guys want to know? Okay, so back in the day, like in the early 1900s, late 1800s, when meteorologists were taking darts and throwing it at a dartboard, right? They were a little smarter than that. I'm going to give us a little credit, right? So what they would do when there was any potential, they would look at the clouds, they have their barometers, they would look at that, and they would have, okay, there's some incoming weather. They didn't know what it was. They didn't know if it was a hurricane. They didn't know if it was a front. Well, they knew what hurricanes were once they happened, but they didn't know what type of weather they were facing. They didn't have satellite, they didn't have anything, they didn't have radar, none of that existed. So what they would do is they would go hoist a red flag and say there's inclement weather headed towards us. So people know there's bad weather coming. And the only thing that stuck with red flag was fire weather conditions. And if you don't believe me, you can check me against Wikipedia. All right, there was one more question. Yeah. Which ones don't? Because we operate on an annual operating plan, and every forecast office in Florida should be doing the same planning. For their zones? Yeah, okay. There are differences with some of those elements. Some of the elements are taken as peak values over the zone, and some of them are taken as averages over the zone, like temperature, for example. Yes, because the extreme is the most important variable that we need. So for for your low RHs and things like that. So this is it right here. So some of these are averages, right? So like the temperatures, but the wind speeds and the gust information are going to be taken as your maximum point in that zone. So. So what I'll do. Hey. Oh, hey, Andrew. Hey, guys. Break it out by early and late, like they have it. Right. That's, if it's a gusty day, y'all put a gusty day, but for them, they've got gusts every day. So we configured that to do that. So it does, over a certain threshold, it comes out. So we do that only usually during the day. So I hope you guys are here. You guys want to come up and talk too? Weather peeps in the house. All right. See one more question. So we do adjustments through the day. We do updates on the fire weather forecasts, but we don't issue fire weather planning forecasts at every update. As far as the planning forecast, it's going to take those maximums and minimums, or maximums generally for both the day and the night. And then for the point forecast, the weather, that will update. If you use that will update, and it will tell you at the top last time it was updated time, and then how long it's been in minutes or hours since then. Correct. So it's not calculating dispersion on the fly. I'll clear that up. It's using dispersion that we've calculated in our forecast database, and it's pulling that information. So it's all calculated on our end, and it just goes to a central database where that's pulled into that web page. Yeah, and that's kind of the nature of the beast with dispersion too. is because you do have some wind adjustment, some wind grace in there that you can kind of hedge a little bit. If you've got lighter winds, you're likely not going to get as good a dispersion as you think, and vice versa with stronger winds. All right. Any other questions before we go to the outlook? Yeah. Mm-hmm. Which county? Which county line? Okay. Because. Okay. Yes. And was that right at the coast? Okay. Yeah, it's probably a difference in wind speed and the wind speed forecast as the dispersion was calculated. And I think I know what you're talking about. So, the question is why sometimes do you see discontinuity in the dispersions or mass differences, large differences between county lines? Often, those county lines are actually probably where you get differences in those weather service offices. Don't we guys? We can attest to this. We try our best to try to make sure that doesn't occur. But dispersion being as sensitive as it is, it can lead to that, but it shouldn't be that large of a difference. I agree. So we do check the dispersions on the maximum sides when we issue the forecast to make sure we don't see any of those large discrepancies between our area and our neighbors. But it is a common occurrence that we try to make sure we get right. But I'll take that back to my office and then share it with my neighbors too about, our partners are using this and they're seeing this, and it's how useful is it for them to make decisions when we have these differences. So making sure we're better coordinated and collaborated. Yeah. There is. We attempt. Like I said, we can get some a little testament here because we've got Tallahassee's basically right here, and I'm out of Jacksonville. They're basically our sister office. I can tell you that I don't think there's as much energy focused in putting in the fire weather forecast for collaboration, but because maybe there's that dispersion, it doesn't seem as big of a difference to some meteorologists as far as it being off by about 10. But it depends if we're near that critical high dispersion level or a low dispersion level where it's a little bit more, care and collaboration, coordination to prevent those large differences, like you said, between Alachua and Levy County. But yeah, I will certainly take that back, and we can talk about it after this and try to make a bigger effort to be more on point between counties. Go ahead. Yeah, and that's us. Yeah, it's exactly, yep. So again, yeah, it's the same, kind of just to beat a dead horse a little bit, but it is an issue, and it's one of those dispersion things. It's kind of the nature of dispersion, and in putting together these forecasts, sometimes you go through the QC, and maybe we can talk about building a better QC for that. We'll see. Yeah. Right. Right. Yeah. I guarantee you, we start looking at winds. Winds and mixing heights are going to be crucial. So your mixing height's also going to be based on some temperatures as well. So there's probably enough discrepancy in given the sensitivity of dispersion that it can lead to more larger than desired changes between those borders. But yeah, that's certainly something we'll take back. I think we can talk about as between our offices and make sure that we do a better point to coordinate that for the future. So because I know I'm running 20 minutes, okay. Oh, that's perfect. And the red flag story. Did you like that, Andy? All right, so I just want to talk about the outlook. First, before we start talking about the outlook, I'll talk about the current status of rainfall, what we've seen. Some areas of the state have been more fortunate than others as far as rainfall is concerned. So we'll talk about that. And first, just look at the last 3 months of the observed precipitation that we've seen across Florida. So this is in inches. Notice there's a lot of red, so some purples in there, some heavy rainfall. You can see this little area here. That was with Hurricane Idalia. A lot of rainfall came in with that system, sheared to the northeast, and laid a good amount of precip. Mostly, between our areas right along the Swanee. And then, so this area I just wanted to highlight, kind of part of the East Coast, because we did have a very somewhat unusual summer, I'd say. We had mostly southwest flow for a good part of the summer, where we had what we call like little troughs coming down, which would keep pushing the sea breeze from the Gulf toward the Atlantic sea breeze. We got more activity for afternoon thunderstorms with sea breeze collision on the East Coast than we did on the West Coast. So, aside from that, we also had fronts come down, and they kind of came through a little bit drier. They would stall south of the Panhandle, so the Panhandle ended up being a little bit drier, as well as some areas along the West Coast. So I like to look at observed precipitation, but you still look at it and say 12 inches of rain is kind of a lot. Well, it depends on where you're at, and we're also in Florida, so you talk about the last 3 months, it may not be that much since we're coming out of summer. So I'll point out the departures from normal. This is the percentage of normal rainfall, and you can see the lower end values here, 25 to 50% floating across the Panhandle, where the conditions are much drier. There's also some lower values because of that westerly wind that we've had, pushing all that. We didn't really have the West Coast areas there on the Gulf get a lot of that, afternoon thunderstorm activity that they usually see. And then a couple little spots there in the Big Bend. Also been a little bit drier and kind of missed some of that rain from Idalia. So how does that translate to some other metrics that we use to make decisions as far as the fuels and the moisture that makes it down into the ground? The KBDIs, this is the KBDI from the Florida Forest Service that was taken 2 days ago. And you can see those areas that were that dry, those ovals will really correspond well to where the KBDIs are a little bit higher. So a little bit drier as far as the soils go, so there's a little bit more deficiency there. And what that turns into is kind of gives us a good proxy for that drought. So Ketchum-Bryant drought index is essentially a drought index. So this is the drought monitor here, and this is the status that we see. So we do have extreme drought ongoing. Like a big part of the Gulf Coast is in drought still, but that's crept into the Panhandle as well. And then it still exists on the Florida Gulf Coast and the Tampa Bay area, all the way down to the southwest Florida coast as well. So these are the areas that we're going to be watching, as we kind of enter that dry season, drier season. But there is good news on that front. So who loves El Nino, La Nina? Who is always following the Climate Prediction Center's weekly? Okay, we got 1. 2. Come on, guys, we're letting ourselves. What are we doing? Okay, so there's an El Nino advisory. It's a good thing for us. It's a great thing for us. Maybe not the Great Lakes, but it's a great thing for us. Not only is there an El Nino advisory, but the El Nino is expected to become a moderate to strong El Nino. So, we just look at sea surface temperatures to help make that distinction. But El Nino is good for us. It gives us a pattern that's more favorable for us to get systems that bring a lot more moisture across the area, potentially more cold front squall lines, things like that, making it all the way down into Florida. And there is, not only is it ongoing, but there is almost a near certainty that it's going to continue through the winter and then also the spring, which is important because the 98 season was and El Nino through the winter. But guess what happened in the spring? Flipped. The rain cut off, and then 98 was 98. So the good news is that the probabilities and all of the models that they use to look at some of the El Nino phase and whether or not it's going to continue do suggest high probabilities that it continues through the spring, which brings me to my outlooks here. And this is provided by the Climate Prediction Center. And these are seasonal outlooks. So the temperature outlook is not too flashy. There's not really much to be said about, if we're going to be too much hotter or much colder than normal. Usually if we're a little bit wetter, usually just a tad bit warmer. But really just kind of equal chances. This is the one that we want to look at. So for the winter time, with that El Nino and the pattern being the predominant basically forcing feature for the systems as they develop along the jet stream, that is going to lead above normal chances across most of the southeast, the deep south, but of course Florida, with likely being above normal for rain chances, which is good for us during our typical dry season that we're looking at. More rainfall, hopefully some of the areas in the panhandle will get some much beneficial rain, needed rain for them, and other areas of the state as well. But that also continues into the spring because there's not really much in way of signs of El Nino fading quickly or reversal of El Nino to La Nina. So there's still chances that we're going to be above normal and in the spring, which will be great because we don't want a lot of moisture, green up, and then drying because that can cause problems for us. But right now, it actually looks like there's a good chance that we'll be above normal through most of the winter and the spring. So that drought outlook, because of that potential wetness that we'll be seeing, where the severe drought is ongoing, it's going to take a little bit more time to improve that, to eradicate the drought and to actually moisten that area back up. But overall, so the signs point to more moisture, so drought removal in some areas will be likely, and then improvement in areas where there's severe drought also looks to be likely in the future as well. So fire potential, a lot of where the southeast is, along the lower Mississippi and into the Ohio River up there, very dry. So that's where the current fire potential outlook exists. It does not exist in Florida right now. This is for above normal potential for significant wildland fire offered by the predictive services. So just some key points I wanted to take away here. Just because we're talking about El Nino doesn't mean we're not going to see the dry frontal passages. In fact, we saw one just yesterday. So it wasn't very dry, but it was breezy. So we're moving into that season. So just be cognizant, this is the time of year where we start to get some of that wind that can cause movement of fire on the ground. But, kind of going through the next couple months with that forecast or the outlook being so wet, the chances for, significant wildland fire between now and December are pretty much fair, equal, just considering those dry fronts. And also, like last year, we had, does anybody remember Christmas? Or did you stay inside and as warm as you possibly could? Because that's what I did. It was very cold. We had widespread killing frosts, multi-day freeze. Not saying it's going to happen again, but we just have to anticipate whether or not we get those, and maybe earlier on that could cause, potentially more dead fuels lying around that could enhance risk. But so kind of taking it into next year with the forecast, the seasonal forecast, we're talking for Florida, if we get as much rain as they think, we're going to be below normal. So it may be hard to put fire to the ground. I mean, I know you guys can do it. I know you'll be able to do it, but it'll be a little bit harder. The fuels will be a little less receptive to wanting to burn, except the palmetto, because it'll burn when it's raining. So the other thing, obviously, is those wetter frontal passages, and more of them, more frequent, will be giving us, should be giving us that wetter winter. So in summary, just some of those products available to you, the planning forecast, the Rawls Point forecast, which I do recommend you use if you can, as far as a comparison to your planning forecast, and then a dashboard as well. And then just a little bit more on the smoke dispersion, just make sure you understand how sensitive it is to transport winds. And if you've got questions, I'm sure I can be second. You can call us and tell us that it's wrong, but you can tell us it's right too. So we accept those. We like kudos. And then the current conditions and outlook, you know, the El Nino, kind of vice versa. We had last year, we had our third La Nina in a row. Luckily, we didn't get away. We got away with minimal fire activity, despite 3 years of La Nina. But we're going through a change this year, a strong El Nino. But we should see drought improvements for the Panhandle area, given the outlook, which is much wetter through the winter and the spring. That's all I have. And if you have any questions, ask my Tallahassee cohort. They have all the answers. No, but if anyone has any questions, I'll take them.